Okay kids, we'll be going with this paper discussion. You can look into the first question. When a light of given wavelength is incident on metallic surface, minimum potential needed to stop, that is stopping potential is 6 volt. Then when you use the other wavelength, which is 4 times, then the stopping potential is 0.6. Then what is the wavelength of the source and what is the work function of the material? So in the first case, you are giving this much energy, out of that some will be going for work function, then potential, 6 electron volt, which I didn't write, right? Remaining energy will be 6 electron volt. From stopping potential we can predict that. Now in the next case, when the wavelength is going to become 4 lambda, then the energy with which it will be coming out will be the maximum kinetic energy will be 0.6 electron volt. So stopping potential will be 0.6 volt. Now I think you need to find phi value and you need to find lambda value. So what I did, I subtracted these two so that I can eliminate phi. So similarly, once I get Hc by lambda, then I can substitute it back and I can get what is the phi value, right? Now you can substitute the values of H and C and you can get lambda value, and phi value is 1.2, right? In the next question, a heavy nucleus half-life is 20 minutes, alpha probability is 60 and beta is 40. Initially 1000 nuclei are there in 1 hour. What is going to happen? So 20 minutes is half-life, so that you can see, like in half-life it is going to become half, in the next half-life it is going to become even half, so that's 20 minutes, 20 minutes, 20 minutes. In 1 hour it is going to become 1000 by 8. So how many are decayed? 1000 were initially there, now the available things are 1000 by 8, so how much is decayed? This much, but out of that only 0.6, that is 60% is alpha decay, that is 525, right? Two hydrogen-like atoms A and B are of different masses. Each atom consists of equal number of protons and neutrons. The energy difference between radiation corresponding to first Balmer series is 5.667. When the atoms are moving with same velocity, strikes heavy target and bound back with the same velocity. In this process, atom B imparts twice the momentum. So basically mass of B is more, so I mean it is imparting more momentum, so its mass will be more. They are traveling with the same velocity, right? So you need to find what is the difference in neutrons in A and B. So there are two situations given. We'll write the two equations. What are those two equations? Balmer series in Balmer, right? So first line of Balmer, this set, right? First Balmer, it will be from 3 to 2, 3 to 2. So this is the energy of first Balmer for a material A. So similarly for material B, it will be this much. The difference is 5.67. From here ZB square minus ZA square you will get, but you are getting only one equation, two unknown. So we need to use some other information. What is that other information? Momentum imparted is twice for B, they said. So mass of A will be related to ZA, mass of B will be related to ZB. Actually it will be 2 times of ZA into mass of proton, 2 times of ZB into mass of proton, but I have written like it will be proportional to ZA, I mean Z, so that you can manage. So this is the momentum of A and this is the momentum of B. Now when they are coming back with the same velocity, then what is the momentum imparted? P minus of minus P, which will be 2 times of momentum, right? 2 times of momentum will be the momentum imparted to the wall. But they said momentum imparted to the wall is P by A and twice by B. So when I take the ratio, I will be getting ZB by ZA is 2 by 1. So there will be two equations, two unknowns, you can solve for them. A particle of charge equal to that of electron charge and mass 208 times of mass of electron moves in circular orbit. Assuming Bohr's model of atom is applicable to this system, find the radius of nth orbit. No, its nth orbit is approximately same as that of first Bohr orbit. Then what is the value of n? So in all these questions, what we will be doing, we will be starting from the scratch for Bohr's model, because they are changing some situations, right? So these are the two things we need to write. Centripetal force will be provided by that electrostatic K, Q1, Q2 by R square, where this is the charge of nucleus and this is the charge of electron, where this is the mass of electron. Now angular momentum will be conserved. From here I have written mv square r mvr, so that I can divide and I can get the velocity, and if I get the velocity I will substitute it here, I will get the radius. Now till here I will be doing in all, that's how we will be doing deriving Bohr's model, right? Now they are talking about the radius. Radius is this thing, radius is this thing. Now what things are changing from hydrogen atom to this thing? Mass, yes, I mean regular Bohr's model to this thing, what they said, mass of electron is changing, charge is remaining same, and Z value is also changing. Z value is going to become Z value, that is this charge capital Q. Capital Q in case of hydrogen is +1, but here it is +3 they said. So now the radius is going to become n square by 208 m when compared to hydrogen, and this is 3 times when compared to hydrogen. N square by 208 3 when compared to hydrogen. For hydrogen it is this. They said first the initial, what is that called, first Bohr orbit. For first Bohr orbit n will be 1 and m will be mass of electron, and this is charge of 1 proton. But in this case n square 208 m and 3, 208 and 3, from there you will be getting the n value approximately 25. A radionuclide A1 with the decay constant lambda 1 transforms into A2 with the decay constant lambda 2, assuming the initial moment the sample content of only radionuclide A1, their numbers are n0. Find the time interval after which the activity of radionuclide A2 reaches its maximum value. So there is a derivation here, I am just putting it here for people who need it. So I won't be explaining it much. Initially this is n0, this is 0, this is 0, and it is decaying, So after some time, if this is n1, n2, n3, now the rate at which this is forming is minus lambda 1 n1, or I can say it is decaying. The rate at which this is forming is because of this one plus lambda 1 n1, but there is a decay minus lambda 2 n2. The rate at which this is forming is lambda 2 n2. But we need this one. This integration we have already done. From here we will be getting n1 equals to n0 into e power minus lambda 1 into t. Now based on this we need to find this number as a function of time. Now for that n1 I have substituted from here. Now this integration is going to be little difficult. I think you people will be having integration factor. So I multiplied with e power lambda 2. Then I will be bringing this term to the other side. Then I can write the same term like this. Then I can integrate on both sides. What are the variables here? N2, t. So what are the values of n2 initially? Initially at time t equals to 0, n2 value is 0. After some time t, what is the value of n2 we need to find. So at t equals to 0. Now when you integrate and when you modify, you will be ending up with this result. So n2 as a function of time. Now this integration will be slightly difficult, but once you look at the solution, it is depending on e power minus lambda t, e power minus lambda 2 into t. So we can predict the solution, right? Predict the solution, it is of this form, n2 is of this form. At t equals to 0, it is 0. So at t equals to 0, when you substitute, this is p plus q. P plus q must be 0. Now dn2 by dt, you will be differentiating this, but what is dn2 by dt? The rate at which n2 is forming. N2 is forming is only lambda 1 n0 initially. So when you substitute it, you will be getting other equation. So at t equals to 0, when you get you will be getting two equations, you will be getting two unknowns. When you solve for them, you will be getting the value of p, you will be getting the value of q. When you substitute it back, you will be getting the value of n2. That's the easy way of getting it back instead of integration. That's the only thing. But whatever it is, you will be getting the result. Anyway, so this question, similar question is there one more. So there I won't be explaining much about the derivation. So let us look here. The time interval after which this is going to become maximum value. That we can do it in a much simpler way. The rate at which it is forming is lambda 1 n1 minus lambda 2 n2. So if this becomes maximum, then this has to become, this has to become maximum, this has to become 0. Or I can say the rate at which it is forming and decaying, if it is equal, then it is going to become maximum. So lambda 1 n1 equals to lambda 2 n2. And n1 value we have just found, n2 value also we have just found, we have substituted it back, we solved for it, and we got at what time? At this much time. So the same thing is there in other question, we will be directly substituting the values there. The wavelength of characteristic X-ray for K alpha of hydrogen is given. So what will be the wavelength of K beta? K alpha in the sense 2 to 1, K beta in the sense 3 to 1. Okay, so it is hydrogen like, so I have taken z square. So if it is not hydrogen like, then we should have taken z minus 1 square. Anyway, that doesn't affect the answer here. So 13.6 into z square by n square, that the difference in the energies will be hc by alpha. When will alpha happen? 2 to 1. When will beta happen? 3 to 1. Now you can take the ratio. When you take the ratio, you will be getting the answer. Fine. Two separate segments of equal area are isolated. Now what does it by equal area? Di by d lambda into d lambda, that is di, area. I mean intensity is going to be same if equal area, equal intensity. That is, you can visualize it like equal energy, right? Number of photons are n1 and n2, energy of photons are e1 and e2. Okay, so you can see lambda 1 is less than lambda 2. So from there we will start it. Lambda 1 is less than lambda 2. So Hc by lambda 1 is greater than Hc by lambda 2. That is, energy of photon 1 is greater than energy of photon 2. But what we know, total energies are same. So if energy of first photon is more, then we need less number of photons to make the same energy. So more number of photons here, less number of photons here, right? So n1 will be less and n2 will be more. Figure shows intensity wavelength relation of X-ray coming out from two different college tubes. The atomic number of target is ZA, and okay, for the second one it is B. So we'll look at A graph is this one. I mean, so wavelength is less. If wavelength is less, what we can predict? See, there will be two kinds of X-rays, continuous. Now this is defined by continuous, right? So what will happen? You will be sending highly energetic electrons. Now those electrons, they will be losing some amount of energy and they will be emitting radiation. But if electron loses entire energy and emit radiation, that is going to give us least wavelength. So more the energy of electron, least the wavelength, right? Or I can say the total kinetic energy of the electron is converted to that photon energy. Or I can say, now we will be accelerating that electron. So energy of the electron. So when you are accelerating the electron, by the time it reaches here, kinetic energy will be E into V. Now that will be totally converted as photon energy, Hc by lambda. So that is the minimum lambda we will be getting. So minimum lambda is inversely proportional to potential difference applied. And according to the figure, it is, according to the figure, lambda A is less than lambda B. Lambda B is greater than lambda A. If lambda B is greater than lambda A, then VA will be greater than VB. That you can do. Now the next one, between ZA and ZB. Now ZA and ZB are the properties of the material, so they will be defined by this K alpha. For K alpha wavelength is less for A and wavelength is more for B. K alpha, how to find K alpha? When it goes from 2 to 1. Now it is not a hydrogen like thing, so we will be taking that shielding effect Z minus 1 square, Hc by lambda alpha, okay, energy difference. So Z minus 1 is inversely proportional to alpha, wavelength, inversely proportional to wavelength. Now wavelength is less for A, so Z value will be more for A, right? A radioactive nucleus decays into, okay, I think this is the same thing with values. The instant at which Ny becomes maximum, what is the population of X? When Y becomes maximum, what is the population of Z? So we have done the derivation. So when it will become, I mean, we have done the same thing for the other question, right? So at this time it is going to become maximum, we are going to substitute the values and we are going to find the time. Once we find the time, we are going to substitute it to get the number of nucleus of the first element, Nx. Now similarly, Ny value also we got, we will substitute it to get the Ny value. Now similarly, if I want, I can get Nz also, but I know total number of nuclei, if they are N0, now they are dividing it, I mean if initial are N0, then now they will be dividing it somewhere, right? So Nx, Ny, Nz. The number of nuclei of Nx plus Ny plus Nz must be constant, which is same as initial one. So we have already calculated Nx, calculated Ny, so we can calculate Nz also. Nz will be N0 minus, right? That much you can manage. But that's not, it's a lengthy question and you can get more marks by doing the first question for this time. Okay, the next question goes like, a heavy nucleus is at rest, undergoes fission, where P and Q are two lighter nuclei. Okay, this is the speed of light. So what's happening? There is a nuclei which is at rest, it is breaking into two parts and they will be moving away. Now if this momentum is P, this momentum will be P, because initial momentum of the system is 0, final momentum of the system must be 0. Now from there I can get option C, that is both momentums must be same in magnitude. So m1 v1 equals to m2 v2. So from there I will be getting option C. Now what is the, from where this energy came? This energy must have come because of the mass difference. What is the mass difference? Delta given in the question. So what is the energy I will be getting from here to here? mc square, delta c square, delta c square. Now this energy is going as kinetic energy of this guy plus kinetic energy of this guy. Now when I modify it, I will be getting the momentum, which will give us option D. Once I get the momentum, I can get the kinetic energy, T square by 2m. I will be getting everything. Any option which is missed? This is option A. Yes, total energy will be mc square, kinetic energy, and option D, momentum, then kinetic energy of P square by 2 times of mass of P square we got, so you can just substitute, but which is not matching because in the numerator there was PQ in the question, sorry, MP in the question. In a radioactive decay, thorium is decaying into whatever, alpha and beta, number of alpha particles and number of beta particles. So you can guess it, but the easy way of doing it is, you will be seeing what is the number difference here. It is 20. This difference will be happening only because of alpha. If there is a difference of 20, 5 alpha particles must be emitted. If 5 alpha particles are getting emitted, there will be a difference of 10 here, but this has to become 282. So there must be 2 beta particles. X-ray again, K alpha for Z, for target A and 2 impurities. Okay, so there are 2 impurities, fine. So I didn't write the equation, it is like Z minus 1 square into 1 by 1 square minus 1 by 2 square, but when I take the ratio, you will be getting Hc by lambda equals, Hc by, 1 by Z is proportional to Z minus 1 square, right? So lambda Z, Z minus 1 square, lambda 1, Z1 minus 1 square, lambda Z, Z minus 1 square, lambda 2, Z2 minus 1 square. They said this is 4 and this is 1 by 4. When you solve it, you will be getting the answer. It's not a big deal. Okay, if the angular momentum of Earth due to its motion around the Sun is quantized using Bohr's relation, the quantum number would be of the order 10 power 74. So what they are saying is, if Earth is rotating, then with a in a radius r, then its angular momentum will be I into omega or mr square into omega. If it is matching with nh by 2 pi, what must be the value of n? Now mass of Earth, radius of circular motion of Earth, omega of Earth and Planck's constant, you have to substitute the values, mass of Earth, radius of the orbit of the Earth and omega value and Planck's constant, you will be getting approximately this much. Now this value is more than 5, so you can round it off to 10, you will be getting the order of 10 power 71. If it is less than 5, the order will be 10 power 70, right? Now after that, I think it's more or less like chemistry question, the next one. Principal quantum number greater than 4 is not allowed. So if any value is 4, then how many elements will be possible? So that depends on the number of electrons permitted, right? So number of electrons permitted are 60, so you can get only 60 elements. Rydberg constant varies with mass number. Consider all the possible cases, that is, you need to consider the reduced mass system also. Generally, if it is hydrogen atom, it is going to look like this. This was some simple. Now you need to convert all the cases to this form. Now in case of simple hydrogen atom, it doesn't depend on the mass number of the element. Now reduced mass system, what is the reduced mass system? If one mass is heavy and one mass is lighter, we will be taking like this is at rest. But if both are comparable masses, they will be rotating about their center of mass. If there is m1, m2, they will be rotating about their center of mass. If the distance between them is r, I will be finding, this will be rotating in radius r1, this will be rotating in radius r2. That radius r1 I can find, it's like m2 into r by m1 plus m2. r1 is m2 into r by m1 plus m2. r2 will be m1 into r by m1 plus m2. I can write like force towards the center equals to m omega square r. I can write for this particle or this particle. Now what is the force between these two? K, q1, q2. You can visualize one as nucleus, one as electron, right? So but if they are comparable masses, they will be rotating about their center of mass. So electrostatic force will be providing the centripetal force. r1 and r2 I can substitute. When I substitute, it will turn out to be like k q1 q2 by r square is mu omega square r. But if you write for Bohr's model, you will be getting it as m omega square r. Instead of m, we are getting mu. What is mu? m1 m2 by m1 plus m2. Now similarly, if I write total angular momentum of this guy is m1 r square omega. For this guy is m2 r square omega, m2 r2 square omega. That must be matching with nh by 2 pi. That's what conservation of angular momentum say, right? Now r1 and r2, when I substitute and when I modify it, I will be ending up with mu r square omega is nh by 2 pi. But if it is simple Bohr's model, I will be getting m r square omega is nh by 2 pi. So it's going to look like simple Bohr's model, but instead of m, we need to replace with mu. This mu value is m1 m2 by m1 plus m2, which depends on the z value, right, which depends on the z value. So what about those? So Rydberg constant is going to depend on the z value. That if you want, you can see, because energy depends on mass, right? If mass depends, this is going to be reduced mass. Kinetic energy, if it is of this form, total energy will be of this form. This is going to be reduced mass in our system. So Rydberg value depends on the mass. Okay, and if it is simple hydrogen atom, then the next option, the ratio is going to be 4. If it is not simple, then we don't know. It all depends on like what is the reduced mass, right? A stationary body explodes into 2 fragments, each of mass 1 kg, that move apart at speeds 0.6 c relative to original body. Find the mass of the original body. See, this is not from syllabus, but still. Initial energy equals to final energy. That's like mass and energy are equivalent to each other. So initial energy is this much. Now that is stationary I am taking. So when I take this as stationary, initial energy is this much. But when something is moving with relative to speed of light, its mass is going to change in this manner. So this is the energy of the second, that I mean m1, and this is m2, but both are equal masses. They said put this as m2, but both are equal masses. When you substitute the value and when you expand it, you will be getting the answer. But if you want any reference for this, you can look into. It's from H.C. Verma. You can look into this copy. Anyway, that's not from the syllabus. You don't have to bother. Going to the next question. A sphere of radius 1 centimeter is placed in the path of parallel beam of light. Intensity of the light is 0.5. If the sphere completely absorbs the radiation falling on it, the force exerted by the light beam on the sphere is. So basically, when light is coming, energy is coming. When energy is there, there will be momentum for the photons. When momentum is there, it will be exerting force. Momentum change happening for 1 second. So photons are coming with some momentum. After hitting, they are going to stop. So the change in momentum in 1 second we need to find. We need to find change in momentum happening in 1 second. Change in momentum happening in 1 second, but we know what is the relation between momentum and energy. So momentum I can write it as E by C. Now energy I can write it as intensity falling on unit area in unit time. Energy falling on unit area per unit time is intensity. So energy I can write it as intensity into area into time, but the time factor is only 1 second. I need to find what is happening in 1 second. Change in momentum happening in 1 second. So time is 1. Now intensity into effective area. As the beam is parallel, then we need to take the effective area of the sphere. Effective area of the sphere is as if you put a torch, what will be the area of the shadow? It is pi r square. So momentum change happening in 1 second. Momentum is related to energy. Energy will be related to intensity. From there we will be getting the required answer. How many head-on elastic collisions must a neutron have with deuterium nuclei to reduce its energy from 6.561 mega electron volt to 1 kilo electron volt? So if mass of neutron is m, if mass of neutron is m, then mass of deuterium will be 2m, because deuterium will have 1 proton and 1 neutron. So if this is coming with u, if it is head-on collision, let us see, head-on elastic, what will happen to the velocities. So let me assume this velocity is v, then this velocity will be v plus u, because velocity of approach is u, so velocity of separation must be u. So this velocity will be u times more than this velocity. I will be applying momentum conservation. Initial momentum is mu, final momentum is mv plus 2mv plus 2mu. So from there when I solve, I will be getting v is minus u by 3, minus u by 3, u minus u by 3 is 2u by 3. Anyway, so the meaning of minus u by 3 is it will be going in the backward direction. Anyway, that does not matter to me. I just want what is the final kinetic energy. Final kinetic energy turned out to be how much? Half m u square by 9, u by 3 whole square. But what is the loss? Half m u square is the initial energy, half m u square by 9 is the final energy. What is the loss? 8 by 9 times of initial energy. 8 by 9 times of initial energy. This is the loss initially. Now how much energy is left? 1 by 9 is left. Out of 1 by 9 in the next collision 8 by 9 will get lost. Now from the remaining again 8 by 9 will get lost. Now this summation must be equals to, okay, this is not the right thing, this is wrong. They said that's the loss, right? Now the loss is going to be total initial energy minus 1 kilo electron volt. Now when you solve it you will be getting the required answer. This is wrong, you just put E naught minus 1 kilo electron volt. The potential energy of a particle is given. Okay, I think that's a easy question. In the first case kinetic energy is E naught, in the second case totally it is, in the first case potential energy is E naught, total energy is E naught, so kinetic energy will be E naught. In the second case potential energy is 0, so totally it will be kinetic energy. Kinetic energy is p square by 2m, so when you take the ratio you will be getting the ratio of momentum, from there you will be getting the ratio of wavelengths. An electron in a hydrogen atom kept at rest jumps from nth shell to nth shell. Suppose instead of emitting electromagnetic wave, the energy released is converted into kinetic energy of the atom. Assume Bohr's model and conservation of angular momentum are valid. If I is the moment of inertia of the angular and the angular velocity of the atom, if I is the moment of inertia, then the angular velocity of the atom about the nucleus is. So, yes. So basically we don't have to do anything. When an electron goes from one orbit to other orbit, there will be change in angular momentum, that is going as angular momentum of the atom, they are saying, right. So I into omega. So this is the reduction in the angular momentum because of the electron jumping. So this is the angular momentum in mth orbit, this is the angular momentum is nth orbit. The difference in the angular momentum is going as angular momentum of the atom. So from there you will be getting the answer. In hydrogen like atom where z equals to 11, nth line of Lyman series has wavelength lambda equals to the de Broglie wavelength of electron in the level from which it is originated. So Lyman in the sense it will be coming to first orbit. So what is the value of n? So 2 to 1 we call it as first Lyman, 3 to 1 we call it as second Lyman. So 2 to 1, 3 to 1, okay, fine. So what they have given? They have said like it is going from, we don't know from which orbit, so let me say x orbit. So 1, 2, 3, 4, so x. So from x it is going to 1. So what is the energy? 13.6 z square into 1 by 1 square plus 1 by minus 1 by x square. So that is first equation. But they said this wavelength is same as wavelength of the electron in that orbit. We know this mvr equals to nh by 2 pi, but that orbit is x I have taken. So when I modify it, I will be getting the value. So okay, that's fine. This r. Now we will be getting r. Now what is the radius? Radius is 0.55 square, I mean 0.529 into n square by z, right? So from there you will be getting the lambda of electron. But they said these two are equal, so you need to equate them. That is going to be a very bad calculation. Finally you will end up with x equals to 25. What does it mean by x equals to 25? Well, it will be coming from x equals to 25 to 1. So 2 to 1 it is first, 3 to 1 it is second. So 25 to 1 it is 24th line. A source contains 2 phosphorus nuclides. Okay, if initially 10% of the decays come from 33p, how long it must take, how long we must wait, so that it will happen 90%. So these are given in the question. Initial activity of the second one, initial activity of the first one, I mean this is the total activity, right? Initial activity of the first one, initial activity of the second one. They said initial activity of the second one is 10% of the total. Now with the time what will happen? This will be the activity of the second one, this will be the activity of the first one, this will be the activity of the second one. Now they said after what time it will become 0.9. So from there we will be getting the relation between lambda 1 n1 and lambda 2 n2 naught. So we can just substitute it back and you can solve for it. That's an easy calculation. Oh, I mean not easy calculation, that's easy manipulation, but calculation is going to be a little hard, I guess. Right? You can manage it. Thank you.